So here in Deltamath, the first one, you're going to have a graph, and you're going to get 2 points. And the goal is to graph the points and then find the middle, or find where is it halfway in between. Okay, so here I'll start with -7, -6. So I'll go over to -7, -6, and plot that point. I just click on it. And then I graph the second point, which is 1, -10. So go over to 1, and then -10. And now what it's going to ask you to do is click and drag to draw a rectangle. Okay. The reason you're drawing a rectangle is only because it just helps you find the middle. Okay. So I'm going to just click on one point and drag over until I get to the other point, like that. So basically I'm putting the corners of the rectangle on each point. And then you'll notice there's like a little like crosshair. There's this little target. The reason for that target is just to kind of help you line up and find the middle. So you see, if I like put it over here, you can see I'm not dividing up the rectangle evenly. But if I put it like right there, you can see that now it's divided up evenly. And now that will show me where the midpoint is. Okay. So the rectangle doesn't honestly really matter. What matters is, where is the middle of that line? Where is it cut in half? Okay. And so I line that up. And if you look up above it, it's -3 for the X value, and then -8 for the Y value. Okay, so that's what I entered here. -3, -8. Okay. I'm signed as a teacher. No, this is. It says it's not okay to be signed as a teacher. Another window. Okay. All right, let me sign out of that and see what happens. That's weird. Maybe I got. Hold on. Let me pause for a second. With that. Okay, so again, this one I'm gonna start with 5, 5. So go over to 5, 5 and graph that. And then I'm going to graph the second point, which is -5. And then +9. So I go up 9 there. And now I'm going to draw that triangle. So I just click on one point and drag it until I get to the other point. And then those little crosshairs show up, and I should be able to, that'll help me find the middle. You can see the middle is literally right there on the y-axis. So that point is 0 and 7. So that's pretty much all you're doing with that. Okay. I'm not correct. What did I do wrong? Anybody see my mistake?
Yes, there's a yellow circle on 5, 5. It should be in the middle when I click it.
I see. All right, so I have to actually click on the middle. I didn't realize that. Okay. So if you guys heard that, you need to click on your midpoint. Okay, so I missed that part. I must have done it on the last one and didn't realize it. All right, so there we go. All right. Pause. All right, so let's go back. All right, so the next one is midpoint formula. Okay, so this is where we're actually going to bust out formula to find the middle. So the other one we graphed it. Here we're actually going to do it by hand, algebraically. So here's an example I'm going to show you guys. So here I got these 2 points, and here's the formula. Okay, so you've just seen this formula in the ed puzzle. Where basically what you're doing is you're going to add up the X values. So 6 plus 10 on top, and then I divide those by 2, and that will give me the X value for the midpoint. And then I do the same thing for the Y values. I add up 7 plus -3, which ends up being just 7 minus 3, and divide those by 2, and that gives me the Y value for that point. So if you look at that on the graph, there's the 2 points. And I'm basically just adding those 2 X values, adding the 2 Y values, dividing them by 2, and that gives me the middle. And when you're thinking about it, when I was talking about we're finding halfway in the middle, we're just dividing those numbers in half. Okay, so that's the whole point of dividing by 2. Okay, so if I'm doing this problem here, and I like this one because I think a lot of times what I'm seeing is people make mistakes with the negatives. Okay, so let's set this up on our notes. So -9, -8, -1, and 2. So -9, -8, And I think it was -1 and 2. Yep. Okay, so what we're looking for here is the midpoint. Okay. So remember with midpoint, it's x1 plus x2. Now you guys have this in the notes. So I mean, you could write this if you want. This part, you don't necessarily have to. Oops, I did that wrong. I shouldn't put parentheses there. But I'm just adding it in there just to make a point. We're adding these up. Okay. Sorry, I put an extra parentheses in there. Okay. All right, so all I'm doing is I'm taking my two x values and I'm going to add those up. So -9 plus, and notice that's a -1. So it's plus -1. All right, and then what we're going to do is divide those by 2. That'll be our x value. And then for the y value, I'm going to take -8 and then add that to 2. And again, divide by 2. Now here's where you got to be careful with the negatives and pluses. If you have plus minus, that literally is the same thing as minus. Okay, if this was negative, which is not in this problem, it's in the distance formula, minus minus, that would be positive. Okay. So then here I can add those two up. So -8 plus 2. Well, they're different signs, so I subtract. I get 6, 8 minus 2. And then 8 is larger, so it should be negative. Okay, I'm going to kind of bring this up here so I save room. Okay, so now -9 minus 2. Well, those are both negative, so I add them, and they become -10. And I'll divide that by 2. Okay, so now I'm basically just dividing these even numbers by 2. That divided by 2 is -5, and that divided by 2 is -3. Okay. So again, what's important is how you set it up. Just be careful with those negatives. Make sure you're paying attention to those as you plug them in. So at midpoint, you're probably going to make less mistakes because honestly, you're just adding. So here, I would see mistakes happening because when you're adding a negative and a positive number, you got to remember to subtract, not actually add them. That's not equal to 10. But it's when you get to the distance formula, that's when you got to be real careful because you're going to be dealing with a lot of negatives. We're going to go to an example that's in the second part of this assignment. You'll see they have the same title, but the difference between that one and the second one is you're not going to end up with whole numbers. Okay, so you're going to end up with a decimal or like a irrational number is what we call it. Okay, so we're going to have -3, and then 1 and 2. So -3, and then 1, 2. Okay, same formula, set it the same way. So we got -3 plus 1, x plus x. So your first x plus the second x, and then we'll divide that by 2. And then for the y, it's going to be -3 plus 2. And again, we'll divide by 2. All right, so here first, we'll do -3 plus 1. Now, again, that's just like this one, where you got a negative plus and then added to a positive. So different sign, subtract 3 minus 1. That's 2, and 3 is negative. The bigger number is negative, so it's negative. And then here, same thing, 3 minus 2. Well, that's 1. The 3 is bigger, so it's negative. Okay, so the first number, if I do -2 divided by 2, well, that's -1. Okay, but 1 divided by 2, I can't divide that. So the question is, what kind of answer does Deltamath want me to give it? Okay. Well, it doesn't really specify. So what I'm going to do is turn it into a decimal, okay? And I have a feeling it'll probably accept both fractions and decimals, okay? So what -1/2 is, if I divide it on the calculator, it's -0.5. Okay, but I also could put negative and -1/2. So both of those would be okay answers. And I'm actually going to try it and see what happens if I put a half. I'm pretty sure a decimal will work, but let's see what happens when I try to put a half. Let's see if it accepts it. So I'm going to put comma, -1 divide half like that. And it accepted the answer. Okay, so you can see that here you can put 0.5 or the fraction. Okay, it'll accept either one. Okay. Okay, so let me pause that so you guys can comment. That's going to be distance formula. So remember the midpoint, looking for the middle. Distance, I want to know how far is it from one point to the next point. Okay, so here in the first assignment, what you're going to do is you have 2 points and you're going to plot them first. Okay, so -4 and 2. And then the second point is 1, 2, right there. And now what you got to do is it's going to ask you find the horizontal distance between the 2 points. So literally you're just counting how far. So 1, 2, 3, 4, 5. That's it. 5 units. So this one's pretty simple, and you're only going to get lines on this one that are straight across or straight up and down. So either horizontal or vertical. And the way they suggest to count it is count how far away it is from the axis on each side and just add that up. So if I count from here to here, well, -4 to the y-axis is 4. And then from the y-axis to 1 is 1. So it's just 4 plus 1. Or you could just literally count each square. So however you want to count it, that's up to you. Okay. So that's pretty much all of these. All of these, you're going to do that. So here, I'll go to, let's see, 2 minus 10. And then 10 minus 10. And just count that distance. 1, 2, 3, 4, 5, 6, 7, 8. And that's it. Okay, so you're just counting the distance. Plot the points, count the distance. Okay, so now the next one. Now you're going to do coordinate distance graphically. And the difference with this one is now the line is diagonal, it's slanted. So it's not going to be as easy as just counting every square. So this is going to kind of guide you, but basically what you're going to do is it says graph a right triangle with the 2 points to form a hypotenuse. So now, if you guessed it, you're going to start using Pythagorean Theorem again. So like we did last week. So here, I want to create a right triangle, and I can do this 2 ways. I can go straight here and down. That's one side or one leg, and then here to here. Oops, I clicked on something extra. That's why I did that. Okay. So that's one way. All right. Another way, let me actually cancel that out, is if I do the right triangle this way. So I can go on either, I don't know why it keeps doing that. I can go on either side of that line and create a right triangle. Doesn't matter which way you do it. I'm just going to go ahead and do it this way. Okay. I don't know why it keeps popping that up or whatever. All right, so now it's going to ask you how long is the leg 1. Well, leg 1, it doesn't matter which one leg 1 is. I'll just say the bottom. That's 2 units long. And then the leg 2 will be this one. So that goes from -2 up to 7. So that's 2 units plus 7 units. That's 9. So that's the second leg. Okay, but now we got to find the hypotenuse because that's what they're asking for. Okay, and if you guys notice here, it says find the distance between the 2 points in the simplest radical form. All right, so let's take some notes on this and so we can see what this means. All right. So here, over on the right, I'm going to write down distance. between 2 points. Now, I'm not going to draw a graph. I'm not going to get all fancy like that. We're just going to kind of draw 1 point like this and kind of just draw a slant and 1 point here. Okay, and then we'll do is we'll just label those points. Again, this is not exact, okay? So it's not an exact graph. We can go 3, 7, and 5, -2. We'll say that's 3, 7, and then 5, -2. All right, so I'm gonna bring out some highlighters for the second part. And then we're gonna make a right triangle out of those 2 points, just like we did on the in Deltamath. So there's my first leg. And then there's my second leg, okay? So the distance here, if we go back to the Deltamath, that was 9 up and down, okay? So basically it's a distance from the -2 up to 7, the y distance. So that's 9. And then right here, that's going from 3 to 5, so that's 2. All right. But the question they want to know is what is, there you go, Savio. The question they want to know is what is the hypotenuse? Okay. So we got to use Pythagorean theorem. Pythagorean theorem, which is a squared plus b squared equals c squared. Now remember, your legs have to be a or b, right? So these have to be the legs, which makes the c your hypotenuse. Okay, I'll pause that for a second. All right, so here, again, we're looking for that distance right there. So let's set it up. These are our legs. Okay, so that we're going to set up as 9 squared, because that'll be an A, or B, doesn't matter. And then 2 is our other leg, so 2 squared equals the C squared. That's what we're looking for, okay? So here first, 9 squared, 9 times 9 is 81. Then 2 squared, multiply 2 twice, so that's 4, 2 times 2, 4. And then we're going to add those together. So we get 85 equals C squared. Now remember, to get rid of a square, because we're trying to get C by itself, we have to square root both sides. And then we end up with C equals, now, if you remember, Deltamath says we want the simplest radical form. So this thing, guys, the square root symbol, let me write it this, that is a radical. So this symbol is the radical symbol. So that's a radical symbol. So what it means is that we want to keep that symbol. Okay, we don't want to get rid of it and actually square root the number and get like some decimal value. We want to keep that number. Okay, so simplest radical form means keep it. Okay. So we'll put simplest radical form. I put it in quotes because you guys are going to see that more than once. Means keep the square root. Okay, so now if I plugged in square root of 85 into a calculator, I get some like number like 9.219 yada yada yada. Okay, so my answer is literally just square root of 85, and I'm just going to keep it like that. So even in Deltamath, that's the answer I'm going to plug in. Okay, so in Deltamath, that's pretty much what I typed. That's why they give you the little symbol here. I put, oops, not over there. Click in the box, click the radical symbol, click square root of 85, and that should be right. Just double check our answer, make sure I didn't make a mistake. Okay, so we're good. Okay, so again, we just had to label those legs, Pythagorean theorem to find the hypotenuse, and then we just keep it in radical form. Okay, so you don't need a calculator unless you just don't know what the, unless you know what the 9 squared or 2 squared or 5 squared, if you don't know your squares, okay? So if you look here, 1, 2, 3, 4, those are all the problems you have. Now, if you notice, it says done. You get one chance with each of these questions where it says graphically. Okay, so if you get it wrong, you're still done with that question. You don't have to go back and do it again. So it might say 0 out of 1, but it will say 100% because you attempted to do the problem. You just got it wrong. Okay, so obviously the goal is try to get it right, but if you don't, you can still move on to the next one and that will be marked as complete. Okay, so then these 3 are the exact same. So you're basically doing 4 of those problems. Okay, the last one, you're going to get 2 points. And now we don't have a graph. We're not going to create a triangle. We just have 2 points, so we need the formula. Okay, so the formula is this guy right here. So you got the big radical symbol, the square root, and inside of that you have both x's together, but now instead of adding, we're subtracting them, and order matters. So you got to make sure you start with the first one and subtract the second one, and then square it. And then you got y, the first y minus the second y and square it. Okay. All right, so let's first write these down. So -8, 1, and -4, -5. -8, 1, and -4, -5. Let's make sure I copied that down right. Okay. All right, so now, again, we're finding the distance. So the formula, I'm actually kind of running out of room here on the side. So the formula, I'm probably going to write it, let's write it like right here. Okay, so the distance, we'll call d, is equal to the square root of first x1 minus x2. All that means is the first x value minus the second one. And then we square that. And we're going to add that to the difference of y1 minus y2. And the reason I say difference, I don't know if you guys remember, difference just means to subtract. The difference of the first y minus the second y, and then we'll square it. Okay, so how we set this up? So first, I'm going to make it kind of big so you guys can see it. First, x1, right? We got x1, x2. So x1 be -8 minus -4. So I need parentheses because I'm doing minus this time. And I need another parentheses to close all of this together. And then I'll have that, then I have to square it. Then in the middle of the 2 parentheses, I'm going to have a plus. So I'm going to add all this together. And then I'm going to be subtracting the first y minus the second y. Actually, let me color code this one too. Okay, I'm also going to color the fact that we have minus in the middle there. Okay. So here it's the first y, 1, minus -5. So again, minus. I don't know if you guys remember in middle school, some of your teachers might have taught you leave, change, or LCC. So we'll use that if you guys remember that, because I know some middle school teachers teach that, leave, change, change. Okay, so I'm just, again, emphasizing that I got to make sure I bring that negative down. That's why I highlighted that. And then I have my blue shows us the y values. Okay, so it all matches up. Okay, so here, I'm going to go ahead and put, this is the distance formula. And then what we're going to do here is leave, change, change. Now, I don't like teach leave, change, change, but I always say it because usually for freshmen, they recognize that, or a lot of freshmen recognize leave, change, change. Okay, so let's finish it up. So if you guys think about Pemdas, I want to start on the inside. So parentheses first. Okay, so again, leave, change, change. I'm going to leave the first sign the same, but I'm going to change, change. So leave this negative, change the plus, change the plus. So new symbol. And we have leave the same. And this becomes plus plus, which is just plus. So I don't have to write two pluses in a row. So, and as you guys know, negative, negative becomes positive. Same thing here, leave. Now there's no symbol written, but there is a plus in front of that one. We just don't write it. So leave, change, change. So these two become both positive. So just 1 plus 5. We can also use that same idea back over here on midpoint. I'll come back over here. So leave stays the same, negative, change to negative, change to positive, but I don't have to write the positive, so it's just negative. Leave, change, oh, these are both positive, so nothing to change there, okay? But again, it's when you have two signs in the middle, okay? Like here, two signs in the middle, that's when we have to do the change. Okay, so now negative 8 plus 4, well, that's going to be negative 4. And then 1 plus 5 is 6. Okay, then negative 4 squared. Remember that squared means multiply it twice. So negative 4 times negative 4 is positive 16. And then 6 times 6 is 36. Then we add those together. So 16 plus 36, that's going to be 52. Okay, now, if you guys know your squares, if I square root 52, that's going to be a decimal. So I got to check back and see what they're asking for. It says round to the nearest tenth. Okay, so we got to round like we did in the last week. Okay. So round to nearest tenth. All right, so I'm gonna use the Desmos calculator. By the way, that last thing that if you're writing it down says round to nearest tenth. All right, so we're gonna do square root of 52. And I need to go to the nearest tenth. So the nearest tenth here is 2, but I need to know the numbers after it to be able to round it. Okay, so I'm gonna write down, all I need, guys, is this number after. I don't need all of these numbers. I don't even need 3 of them. So all we're gonna write down is 7.21 because all I need is one number after it to be able to round. So 7.21, if you guys remember, I'm gonna stop here, but then I have to look here. So you guys remember, if this might help, if that number right there, if it's 0, 1, 2, 3, or 4, then this number is going to stay. But as soon as I get to 5 or more, that's when I know I got to go up. So 1 will make the 2 stay, so I just have 7.2. So that ends up being our distance. Now, is there an easier way to do all of that calculating? Because if you notice, it was 1, 2, 3, 4, 5, 6 steps. Could I simplify that? Yes, you can. And what I could do is I can actually go to Desmos, and what I'll do is type this entire expression right here. And I'll show you how to do that. So what I'm going to do here is type -8 and then minus -4 and then parentheses and then squared plus 1 minus -5 and then squared. Okay, and then look what I get. There's the answer. But what's important is that that radical, guys, you got to make sure it goes over the whole expression. Make sure it goes over the whole thing. So like, for instance, let's say you typed it and it looks like this. That will be wrong. You're going to get a different answer. Actually, it might even give you an error. Let's say I get rid of that plus. It might give you that and you're like, oh, it's 144. But you forgot that the radical has to be over the whole thing. Okay. So make sure that it's over the whole thing, and just make sure that your negatives match up. Make sure you got the negatives in the right place, and then you should be good, okay? So what would that mean for showing work if you did it that way? What I want to see then in your work is I want to see you at least set it up, show this number, and then round it, okay? So if you decide to type that whole thing in Desmos, make sure I see that whole setup, that first step in your notebook or wherever you write it down, okay?